Hello and welcome to the latest edition of the Which EV podcast. I'm Which EV's editor James Morris, and today we have something a bit different. We have a special report about the possibilities and difficulties of battery recycling made by our writer Gian Matteo Sacchetti. So without further ado, I'll hand it over to Gian Matteo.
In 2030 we're going from this to this. The UK government has imposed a ban on the sales of internal combustion engines, which means no more diesel and no more petrol. In 2030, people will be only allowed to buy electric or hydrogen vehicles. In the world, there are currently over 7 million electric vehicles. And according to a report by the International Energy Agency, their number will skyrocket to over 130 million EVs on the road in just 10 years. The advent of this new technology will help us with a zero greenhouse emission challenge. However, it will also create a challenge of its own. How are we going to recycle them? The process is not straightforward, as there are a lot of factors to take into account. Lack of uniformity.
It's not standardized yet, neither in chemistry nor in geometry or other aspects.
Lack of an infrastructure to recycle.
You need different systems in place. You can't just take the current system, which is to crush everything.
And the fact that right now, in this moment in time, direct recycling is not the most profitable solution.
Batteries have got more value in them when they're able to go into a second life application, you know.
So, with that in mind, let's take a drive on the winding road of recycling EV batteries. The first mass-produced electric car was designed in the mid-90s. However, the technology used for the battery is still rather new, because it is constantly developing as automakers are trying to match the range of internal combustion engines. Due to this reason, there is not a unique formula for the internal chemistry of the batteries. The wide variety represents a challenge in the recycling process. Electrical engineer Carlos Larrea León.
Each OEM uses a different battery with a different chemistry and also with a different geometry of the cells. So the process has to be changed completely for the different kind of battery. So you have to buy new machines, you have to design a new process for each battery of each OEM.
The range of electric batteries is one of the most important aspects for automakers, as it is a key component of the marketability of their product. Each of the brands is engineering their own chemistry balance to try to dominate this particular sector of the market. Therefore, it is unrealistic that we will ever see a standardized battery chemistry in the future. Maria Kelleher, environmental engineer specializing in waste management issues.
In theory, it would be great if they decided on one common chemistry. I think that's highly unlikely. Just the way the automakers, they are competitors. The battery chemistry gives them an advantage, among each other. So I would be very surprised if they standardized on one chemistry.
This new technology requires heavy investments from the automaker, as the transition from an internal combustion engine past to an electric future is not easy. Therefore, in this particular moment in time, the auto industry is concentrating its efforts to improve electric batteries' range and not necessarily on recycle them once the decay process starts. Dr. Gavin Harper, professor at Birmingham University and leading expert on the recycling of lithium-ion batteries.
At the moment, lithium-ion batteries aren't optimised to be designed for recycling. Manufacturers face a real challenge getting electric vehicles onto the market, and their focus at the moment isn't necessarily on what happens to that vehicle when it reaches the end of its life.
Due to that reason, the recovery of the materials used in the batteries become even more challenging. The diversity of the EV batteries is not the only issue right now, as there is a lack of recycling facilities in the country, as Dr. Harper has highlighted in his research.
Don't currently have an active recycling facility that's working in the UK. In an event with Brexit at the end of the year, that could present real challenges around our ability to export battery waste.
The fact that we do not have an infrastructure might not be a pressing issue at this moment in time, as not a lot of EVs have reached yet their end of life. However, if we do not act soon, it could become a problem. That is why Andrew Abbott, professor of physical chemistry at the University of Leicester, is leading the Raleigh project, which will guide the government in the development of a large infrastructure.
500,000 vehicles will come to end of life by 2030. How do you actually deal with that physically? Bear in mind there's probably only about 10 people in the UK at the moment who are trained to be able to dismantle a vehicle. And so it's important now to start now to be able to be in a position where you can handle it in 2030.
The focus of the Raleigh project is to find the most efficient way of recycling the lithium-ion batteries.
The big problem that you've got there is that, how do you physically take apart this cell, which may contain up to sort of 6,000 or 7,000, small cells. Our belief is that where we want to be in 10 years' time is a battery that you can pull apart and you can take the individual electrodes and then delaminate the electrodes. And then the beauty of that is that it's cheaper to do and you end up with purer materials.
Currently, there are multiple methods to take care of the batteries, but according to Harper, they all have different issues.
With pyrometallurgical recovery, the easiest way to think about that is that batteries go into a furnace. The challenge is that some of the materials like the lithium, the aluminium, the manganese and the plastics will end up converted into a form where it's very difficult to be able to use them or do anything useful with them without investing an awful lot of energy. But the thing is that it's very easy to recover the valuable materials like cobalt and nickel, and then the hydrometallurgical process. And so the challenge is finding the right liquids that are able to be selective and leach out certain components of the battery, but not other components of the battery.
Also, it needs to be taken into account the fact that the majority of the batteries can have a second life before being recycled. Due to the fact that there is not an efficient way of recycling, second life applications become the optimal solution for lithium-ion batteries, as it is pointed out by Larrea, León.
It's not sustainable. So if you have to spend 100 euros in recycling to get 80 euros in the materials. So the process is not sustainable, economically sustainable. So we need to reuse them to get more value out of them.
BeePlanet factory in Navarra, Spain, where Larrea works, is a company that helps automakers such as Nissan repurposing their EV batteries that still have a lot of power left in them.
There's plenty of energy in the batteries, up to 80% when we receive them. So it makes a lot of sense to use those batteries for other purposes.
There are quite a few different second life applications, such as
for residential applications, also for large-scale installations, for big energy players that require batteries for the renewable energy power plants, either wind power or solar photovoltaic, so that they can provide a constant amount of power generated instead of very uncontinuous.
Clearly, it is beneficial for batteries to have a second life. So why is it necessary to recycle them and create an infrastructure anyways? The projected estimates show that in the future there will be millions of electric vehicles on the road. However, certain materials in the batteries are not unlimited. Professor Harper.
The challenge that we've got is that potentially the world is going to face real constraints around the supply of cobalt if demand for electric vehicle batteries rises rapidly, but the supply chain isn't able to keep pace.
Also, recycling expert pointed out another issue, which is that 60% of the cobalt supply in the world comes from a country known for illegal mining, human rights abuse, and corruption. Environmental engineer Kelleher.
There's plenty of lithium in the world, but cobalt is a problem because most of the cobalt is in the Democratic Republic of Congo, and it is a very violent, unstable country, and that's the problem. So the cobalt is really the issue people worry about, and cobalt is very expensive. So it's not only expensive, it comes from crazy places.
That is why it is necessary to create a functional recycle infrastructure in order to create a circular economy that will allow EV battery to be more sustainable.
The circular economy is important because the idea is that you don't take something, use it, and dispose of it. You take something, use it, and then get it back into the economy, so that if you put everything back in a circular economy, you have to do less mining, so you do less environmental damage.
Clearly, the recycling of EV batteries is still in an embryonic phase. However, according to Larrea León, experts agree on one thing, which is that internal combustion engines are not sustainable.
The future cannot be based on internal combustion engines. And electric cars are the future. They are more efficient. They are more sustainable, less CO2 emissions. So it's like the next step.
Indeed, it is the next step to a greener future.
Thank you, Gian Matteo. This has been the Which EV podcast, and you've been a great audience. Tune in next time when we return to our usual chat and analysis of the latest EV stories. Follow us on Facebook, Twitter, LinkedIn and Instagram. And of course, please come back to our website, whichev.net, for the most recent news, reviews and features on everything electric vehicle. We'll talk to you next time.